from the homework?
61.
61. All right. So, from the start to the end. From the start to the end. Okay? So, how much are peanuts?
280.
280?
380 for cashew.
530.
330. Oh yeah, it's 530. 7 minus 530.
And then it was $5.30 for cashews per pound.
Yep.
And then we're selling the mix at $3.30. And how much of the mix are we making?
100 pounds.
Okay. So, you okay with P's and C's?
Yep.
Yep. Okay. So, however many peanuts I put in, plus however many cashews I put in, is going to give me 100 pounds in my mix. Right?
Yep.
Okay. Then, for every pound of peanuts I put into the mix, that's going to cost me $2.80. For every pound of cashews I put in, that's going to cost me $5.30. All told, I'm selling the mix at $3.30 per pound, and I've got 100 pounds of it. Okay. So if I rewrite that bottom one, okay, I could rewrite it on the right side with just 330 there. Okay? What's it set up for? It's pretty close to a substitution, right? Take the top one, and if I solve for, you want to solve for P or for C? C? Okay? So if I take this top one and I solve it for C, then I get 100 minus P. Okay? So then I plug that into my other equation, 2.80P plus 5.30 times 100 minus P equals 330. .80P plus 530 minus 5.30P equals 330. Negative 2.50P equals negative 200. So P is 80. So if I've got 80 pounds of peanuts, how many pounds of cashews do I have? 20. So today we're going to go on to 3 equations with 3 unknowns. Okay? Systems with 3 variables. By the way, the turn-in folder's up there. Sunshine just put hers in there, so at some point in time, make sure that those day 2s get there. Okay? Now, with equations and 3 variables, or systems with 3 variables. By the way, if you haven't noticed, for every variable that you have, you need an equation. Okay? So if you have 1 variable, you only need 1 equation to solve it. If you have 2 variables, you need 2 equations to solve it. If you have 3 variables, you need 3 equations. 4 variables, 4 equations, and so on and so forth. Okay? This is not called an ordered pair anymore. Okay? An ordered pair is the fancy way of saying point. Okay? This is a point in 3 dimensions, and so we call it an ordered triple. Okay? So this is called, this right here is called an ordered triple. An ordered triple has x first, y second, and z third. Okay? Or a first, b second, and c third. They're alphabetical order inside of there, depending upon whatever your variable is. Okay? So if we have problems like, is that ordered triple a solution to this system, you can answer that quite easily by simply plugging in those values into all 3 of the equations. Now, you don't get by with plugging it into just one of the equations. You don't get by with plugging it into 2 of the equations. You have to plug it in to all 3 of the equations. And if it's truly a solution to that system, you will get 3 true statements then by plugging it into all 3 systems, or all 3 equations. Okay? So, this becomes 2 times 7 plus 5 times 1 plus 3 times negative 3. And that, hopefully, is equal to 10. Well, that's 14, that's 5, and that's negative 9. 14 plus 5 is 19, minus 9 is 10, and 10 is equal to 10. So it checks out in the first equation. Then you go on. Now, if it didn't check out in the first equation, do you have to go on?
No.
No. That's the good part. If it doesn't work in one of them, you can stop. Okay? But if it works in one, then you go to the next one. So then the next one would be 3 times 7 minus 1 plus 4 times negative 3. And that's got to equal 8. 3 times 7 is 21, minus 1 is 20, minus 12 is 8. And 8 is equal to 8. So we're good so far. Then we got to check it in the last one. 5 times 7 minus 2 times 1 plus 7 times negative 3 has to equal positive 12. 35 minus 2 minus 21 is 12 is equal to 12. So it checked out into all 3 of them. So, yes, it is a solution. Now, 3 equations, 3 unknowns, create in them more work. Because you've got another equation, so you've got to do more work. Okay? Sorry, there's just no way around it. Okay? So don't try and cram these problems, especially like this one. It says solve this system using elimination. Okay? Don't try and cram this into a little section. Okay? You're probably going to get something lost, make something miss, etc. Okay? All right? You forgot your water bottle, Mr. Wendling. Okay? It's yours. Is it yours? Okay. It was just sticking out, so that's why I noticed it.
Almost dehydrated.
I was gonna say you were 45 minutes away from me bringing it to you, so
Thank you.
no problem. Okay. So when we're solving using elimination, the first thing that we have to do is we just simply have to pick a variable that we are going to eliminate. Okay? So we need to pick x, y, or z. X. Does it matter? Does it really matter? No. Looking at this particular one, okay, if I go with x's, I can add the first and the third equation together, right? And that would eliminate them. Okay? If I go with z, I'd have to multiply the third equation by 5 and add the first one, or multiply by negative. You know, it doesn't really matter. Okay? It really does not matter. Okay? One little habit that I have with 3 equations is I like to number using Roman numerals, because then they don't get confused with actual numbers in the equation. But I like to go with Roman numerals on the equations. Okay? So x, we all okay with x? Eliminating x?
Yeah.
Yeah? Okay. Everybody's okay with eliminating x? Okay. Well, we're going to have to eliminate x then twice. We're going to have to do that twice. So the first time, let's take the easy one. Okay. Let's add equation number 1 to equation number 3. If I add equation number 1, negative 2x plus 4y plus 5z equals 5, to equation 2x plus 5y minus z equals negative 12. If I add those two together, I get, these go away, 9y plus 4z equals negative 7. Okay. Now, I've got to eliminate x again. What do you want to go with? I can't use 1 and 3 because I already used those. 2 and 1 or 3, doesn't matter. 1, okay? So if I'm going to use 2 and 1, then I'm probably going to have to go 5, oops, wrong color. I'm going to have to go with 5 times equation number 1 plus 2 times equation number 2. Five times equation number 1 is negative 10x plus 20y plus 25z equals 25. 2 times equation number 2 is 10x plus 4y minus 6z equals negative 2. that gives me 24y plus 19z equals 23. Okay, so I've eliminated x twice, which created two new equations, 4 and 5. Now, with the equations 4 and 5, I can run elimination or substitution or graphing on those two. Okay? Graphing? Yeah? No? Nobody wants to graph? I get it. I really don't either. Okay. Substitution? Yeah? Yeah? Is there a good one to solve for? Nope, I don't like substitution either. So we got to set up elimination. Okay? So you want to eliminate y or z? Alright.
Y.
Let's eliminate y. Okay? So if I'm going to eliminate y, then I'm going to go up to 72. So I'm going to go negative 8 times equation number 4 plus 3 times equation number 5. So that's going to be negative 72y minus 32z equals positive 56. Three times equation number 5 is 72y plus 57. Z equals 69. $25. So I get Z equals 5. Now what? Solve for what? Into the fourth equation?
Yeah.
Okay. So if we're going to put z equals 5 into the fourth equation, whoa, what the heck happened there? That was great. So if we're going z equals 5 into equation number 4, then that's going to give me 9y plus 20 equals negative 7, right? So then that's going to give me 9y equals negative 27. So that's going to give me y equals negative 3.
What's the values in the equation? 1, 2, or 3?
Either any equation, 1, 2, or 3. Okay? So we're going to plug those two variables into an original equation. Yep. If you want to know if you're right or not. You know what I mean? So if I plug them into 3, so then that's going to be 2x plus 5y. So that's going to be 5 times negative 3 minus z,
minus 25.
which is 5. No, not 25, just 5. That's going to then have to equal negative 12. So 2x, well, that should have been negative 3. That's right. Minus 15 minus 5 is minus 20 equals negative 12. So 2x equals 8. So x equals 4. Okay. So, checking it now, I'll scroll back up to the original equations. Negative 8 plus negative 12 is negative 20, plus 25 is 5. 20 plus negative 6 is 14, minus 15 is negative 1. 8 minus 15 is negative 7, minus 5 is negative 12. It works out, it checks out, so I write my answer as an ordered triple, 4, comma, negative 3, comma, 5.
So would there be a case with the checking that one of the 3 wouldn't work out?
Then you did something wrong.
So I think it would work out 2 and not 3.
Then you did something wrong.
Okay.
So then it wouldn't work.
But it's not like all in.
It's all or nothing.
No, I'm saying so like in the 3 is it so
When you're checking and you get something that's not true, you've done something wrong, so your answer is wrong. Yeah. Or your checking was wrong. Yeah. Something in there is wrong.
So you need to check all of them. So
Yes.
Okay.
Yes. You can't just get away with checking one. Yes. You have to check them all to make sure that you're right. Yes, ma'am. Step number 4. Plug it back in. Okay? Now, that's one way of doing it. Okay? There's another way.
Get faster.
Sometimes, sometimes not. Okay? We'll learn a third way that's much faster. But we won't learn that for another couple weeks. Okay? Substitution is another way. With substitution, step number 1 now says we need to pick a variable to substitute. So, again, you've got 3 choices, x, y, or z. Y? Okay. Which equation do you want to solve for y? The first one. Okay. So if I take the first equation for y, that would give me y equals 10 minus 3x plus 2z. Agree? Yeah. Now, in step 2, you're going to substitute that into the other 2 equations. So, in equation number 2, it's going to be 6x minus 2 times 10 minus 3x plus 2z plus z equals negative 2. X minus 20 plus 6x minus 4z plus z equals negative 2. 12x minus 3z equals 18.
Where are you getting 18?
They added 20
Yeah,
both
I
sides.
have to do it.
Plus it. Call that equation number 4. Okay. Then we got to put it into equation number 3. X plus 4 times 10 minus 3x plus 2z plus 3z equals 7. X plus 40 minus 12x plus 8z plus 3z equals 7. Call it equation number 5. What do we got? Negative 11x plus 11z equals negative 33. What do you want to do with 3 and 4, or excuse me, with 4 and 5 now?
Solve for another variable.
Substitution or elimination? Did elimination once, right? Let's do substitution. Huh? So if I take equation number 5 here and solve it for what? Z? I solved equation number 5 for Z. Okay? So then I plug that into equation number 4. $12x minus 3 times x minus 3 equals 18. I get x equals 1. Yeah? What's up?
I'll play on that one would be negative 13x.
1 minus 12 is? 1 minus 12 is negative 11.
Yeah. Why would you subtract x?
Because I
You just added. Okay.
have to combine them.
Added.
Yeah.
That was good.
1 plus negative 12 is the same as 1 minus 12.
Okay.
Yep. So what do I want to do with x equals 1?
Put it back in the equation.
Which one? 4 or 5? 4? Okay. So if I put it back into equation number 4, then I get 12 minus 3z equals 18. Oops, I should make that bigger. So then we get negative 3z equals 6. So z equals negative 2. Now what?
Where are you getting x minus 3?
This?
No.
This?
Yeah.
From right here. We took this equation, equation number 5, okay, and then solved it for z, got this, right?
Why are you going back to 4?
Because I got to put it back into the other one. I can't put it back into equation number 5. I got to put it back into the other equation in that particular system. Okay? Now what?
Those two back in the equation that we're solving out.
Bingo. Yep. Okay. Which one you want to do? Number 3. Why would you choose number 3? We're solving for y.
Oh,
Wouldn't I choose number 1?
yeah.
Because it's just y by itself, right? Okay. So 3 times my x value of 1 plus y minus 2 times negative 2 has to equal 10. So that's 3 plus y plus 4 equals 10. So y equals 3.
Where are you getting another 4?
What other 4? This 4?
Oh. You got this equation was 3 there.
This one?
Because you have that 4.
Right there. We solved this one for x. Let's see if I can get them on the same. I had them before. Okay? So after we got done solving this for x, okay, then we took that, we put it back into equation number 4. I could have put it into either 4 or 5, okay, and got what z was. So now I got x and z. So then now we put that back into equation number 1 and got what y is. Okay?
So, the only time you would go back to the original problem is the last step.
Yep. So then our order triple is 1, comma 3, comma negative 2. Checking it. Way back up top. 3 plus 3 is 6. Minus negative 4 is 10. 6 minus 6 is 0. Plus negative 2 is negative 2. 1 plus 12 is 13. Minus 6 is 7. So it works out. Okay. 3 equations, 3 unknowns come in word form too. Okay? So I'll give you a couple of minutes to develop your 3 equations with your 3 variables. Solve it, check it, and present your answer. I'm an X, Y, and Z kind of a guy. If you wanted to go A, B, and C, that's cool. If you wanted to go P, Q, and R, that's cool. All right. First sentence says the sum of 3 numbers is 6. Matt, talk to me.
X plus Y plus Z equals 6. You put the dash in the Z.
Because then it doesn't look like a 2. Okay. Third number is the sum of the first and second number. Give me an equation, somebody, out of that one. So mine would be X plus Y equals Z. Third sentence says the first number is 1 more than the third number.
So it's going to be X minus Z. Right?
What?
It's going to be X minus Z if the first number is 1 more than the third.
So the first number is X, right?
Yep.
So X equals Z plus 1. Okay. How do you want to solve it? What you got? Plug X into equations 1 and 2. Right? So if I plug it in equation number 1, then I get X. No, I don't get X. I get Z plus 1 plus Y plus Z equals 6. Correct? So that's Y plus 2Z equals 5. Subtract it.
That's where the 5 came from.
That's why it's non-simple. Okay. Then I put it in equation number 2. So that becomes then Z plus 1 plus Y equals Z. That gives me Y equals -1. Right?
Well, what are you doing with the Y plus 2Z equals 5?
What do I do with the Y plus 2Z equals 5 then? So what do I do with this equation over here, this equation 4? If Y is -1. What? Put -1 in for Y, right?
Z equals 3. And you put both of those into one of the
Which one would you put it into? 1, 2, or 3? No.
2.
3.
There's no y.
Because there's no y. So then I don't have to worry about it. So if I just, and I'm looking for x, right? So I'm going to go into 3, because 3 is just x and z. So if z here is 3, x then is going to equal 3 plus 1. So x equals 4. So now, go back to your original problem. The sum of three numbers is 6. 4 plus negative 1 is 3, plus 3 is 6. Works out. The third number, 3, is the sum of the first and the second numbers. 4 plus negative 1 is 3. The first number, 4, is 1 more than the third number, 3. Works out. Now, can I just say the three numbers are 4, negative 1, and 3? I have to put them in order, not in an ordered triple. Okay?
In number order.
No, not in number order. I have to go, the first number is 4. The second number is negative 1. The third number is 3. Okay?
Is this going to be in the test one?
Possibly. Yeah. You have a quiz, not a test. Yeah. But yeah, you do have a quiz tomorrow along with some homework. So this was, what section are we in? 3.4. I shortened it way down. The original one was 3 to 19 odd, 31 to 35 odd.